So as part of our test review for this particular unit, again, we looked at exponent laws, we looked at determining characteristics of exponential relationships, we looked at rates of simple increase, simple decrease, as well as half-life and doubling time. So as part of our review, we're going to go over all those pieces, and we'll start off doing a quick review of exponent laws. So on your test, for example, you will be asked to write final answers as both a single positive power and to express it as a final number. And to that effect, we need to apply our exponent laws as we have them. So again, exponent laws only ever apply when you have powers with the same base. When you have powers with the same base that are being multiplied, you add the exponents. When you have powers with the same base that are being divided, you subtract. When they are powers of a power, you multiply the exponents. When they're negative um, exponents, then you flip the base, and that makes the exponent positive, and any number to the power of 0 or to the exponent 0 is equal to 1. So let's take a look at this first example. We've got a base of -3. We've got two exponents that are being multiplied, or two powers that are being multiplied. So in this case, we add the exponents, so 3 plus 1. So -3 to the exponent 4, and then -3 to the exponent 4 is going to be 81. Okay. The next example here, we've got two powers with the same base. They're being subtracted. So we subtract the bases from each other. Sorry, the exponents from each other. So we end up with 5 squared. 5 squared is equal to 25. Here we've got a situation where we've got a fraction as our exponent, or as our base rather. Our exponents are being multiplied. So we're going to add them together, or our powers rather being multiplied, so we add the exponents. So 3 plus 2. So that gives us, oh dear, let me correct that. 1/2 to the exponent 5, which is the same as 1 over 32. Okay. Again, remember, whenever you're doing a fraction, you apply the exponent to the top number and to the bottom number. Okay. So 1 to basically any exponent is always 1, but 2 to the exponent 5 is 32. So down here, again, same base in terms of both powers, base 6. So I've got -3 subtract -1 because they're being divided. So -3 minus -1 gives me -2. So right now I've got a power with a negative exponent, and I need to turn that into a positive exponent. So that gives me 1 over 6 to the power of 2, because the inverse, if I flip the base, then instead of having 6, it becomes 1 over 6. So I end up with 1 over 36 as my final answer. Here I've got a power of a power, or an exponent to a power. So my base is still -2. I've got exponents that are being multiplied. So in this case, I end up with -2 to the exponent 6. Oh, let me try that again. I end up with -2 to the exponent 6. And -2 to the exponent 6 is going to give me 64. Over here, I've got, again, same base of 4. I've got -2 plus -3. So this leaves me with, so if I do -2 plus -3, that leaves me with -5. So I want to get rid of the negative exponent. That means I have to flip the base. So it becomes 1 over 4, and then power of +5. So I end up with, 4 to the exponent 5 1 over 1024. Okay. And then the final question here, I've got a situation where I have a power raised to an exponent, my base 5, and I'm going to do 0 times 4. That leaves me 5 to the exponent 0. Any number raised to the exponent 0 is going to give me 1. So that was just a quick review of exponent laws.